In this video, I will explain the rules for differentiation, and this time the rule is quotient, derivative of a quotient of two functions. So this is the function f of x, and it looks like it's a quotient. So we have to solve this a different way, not the quotient rule. Right now, we have to rewrite this question. So I'm going to rewrite this function as a function in polynomial form, then we find the f prime x. So I'm going to rewrite it, and there are several ways that you can rewrite this function. One thing is I can do the 2x cubed minus 3x squared plus 2 within the parentheses, and I can move this up there because if the fraction you change into a multiplication, you have to do the reciprocal of that. So times x negative 2. The 2 jump to the top and it turns negative exponent. That's how it works. So we can do this. We can distribute this x to the power negative 2 with each term here, and then we can get a polynomial. Another way also we have where we can get the same answer, we can split the fractions, like 2x cubed has x squared in the bottom, 3x squared has x squared in the bottom, and we have a plus 2 and x squared in the bottom. So you can apply the exponential property, same basis you divide, you subtract the exponents. You can apply that property here. In here, I'm applying the exponential property. When you multiply same basis, you add exponents. So up here, I'm adding exponents. Up here, I'm subtracting exponents. So let's distribute. X negative 2 times 2x cubed. So since we have same basis that multiplying, we add exponents. 3 plus negative 2 is going to give me 2x, 3 subtract 2 is going to be 1. So here we go. Then x negative 2 times negative 3, which is 3, x squared and negative 2, you subtract, it's going to give me x to the power 0 plus 2x to the power negative 2. Now let's fix it again, and one step at a time. This one is going to give me 2x minus 3. That one is going to give me still 2. And since x has a negative exponent, we have to turn it to positive 1 and move it down. So it's going to give me 2 over x squared. Or let's not move it down. Let's take a derivative, and then we can see if we have a let's see if we have a negative exponent, then we can fix it around. Now let's take a derivative of this function. F prime x equal 2x derivative is 2, 3 derivative is 0. This one is negative 2 times 2 is negative 4, and x to the power negative 2 subtract 1 is negative 3. So yes, we do have a negative exponent. So let's fix that now. F prime x equal 2 minus 4 x to the power 3. Now, if we have one fraction and one term is not a fraction, then we have to find least common denominator. And remember the 4 steps of 4 functions operations that we use if we get stuck after the calculus part. Least common denominator, we're going to find common factor. These are few things that we consider: least common, common factor, distribute, or foiling. So these 4 things. In here, I can do least common denominator. X cubed times 1 is going to give me x cubed. Cross multiply, 2 times x cubed is 2x cubed minus 4 times 1 is 4. So this is what the answer is for the f prime. After that, we can't do anything. So this is my, oh, actually, I'm sorry. This one is my answer, which I messed it up. Here we go. That's my answer. I can click on this. Okay, let's try the next one. Okay, so the answer we got is 2x cubed minus 4 over x cubed, and that's actually what we need for this f prime. So that's my answer right there for the f prime. Now let's find out what is the quotient rule. If you guys pay attention, I rewrote the question and I just apply exponential properties. Like same basis multiply, you add exponents, same basis you divide, you subtract exponents, and then I applied a simple power rule derivative. Now we're gonna look for the quotient rule. What is a quotient rule? Quotient rule said if hx is equal f of x, like one function is on the top, another function g of x is on the bottom, like it's a quotient, then what is the rule? According to the rule, we say keep the g as it is times a f prime x minus, remember the product rule was addition in between them, for the quotient it's minus. Then we keep the f of x as original times the g prime x. There. Divide by g of x whole squared. So it's going to go square, the original g, the one in the bottom. So let's apply the quotient rule on this question. Okay, in this one, that's my f and that's my g. So let's try f prime x, and we already know the rule for the quotient, it's right here. So I'm going to keep the g function as it is, like a x squared times and derivative of f prime, and this is my f function, so I'm going to take a derivative of that, 6x squared minus 6x, done, minus, then we have a f of x original, parentheses, 2x cubed minus 3x squared plus 2, because the numerator is the f, g prime x, the derivative of g, which is 2x in this case, bottom, I'm going to keep x squared, g function whole squared. Now we just have to fix it around. The calculus part is done. So if we get stuck after calculus, remember these 4 things: LCD, common factor, distribute, FOIL. In this case, I'm doing the distribution. So let's try and distribute f prime x equal x squared times 6x to the power 4 minus 6x cubed, and then I'm going to keep minus and big bracket. I want to FOIL or distribute this 2x first, and then I'm going to distribute the minus sign because I don't want any mistakes. 2x and 2x cubed is going to give me 4x to the power 4 plus 2 and 3, I'm sorry, not plus, minus 3 and 2 is 6x cubed, positive and positive is 4x, and done. And in the bottom we still have that x to the power 4. If it's something like easy like that, then I will do it, otherwise we don't touch the denominators. Now I have to do next step, f prime x equal, I'm going to erase that, f prime x equal, distribute negative. So I have 6x to the power 4 minus 6x cubed plus minus 4x to the power 4 plus 6x cubed minus 4x, and in the bottom we have still that x to the power 4. Now let's try after this. What is the next step? Combine like terms. So 6x cubed cancel out, 4 and 4 we subtract, so we got 2x4 minus 4x over x to the power 4. Now this is my derivative. I can also do the common factor, like 2x is a common factor, I can do that, or I can split the fraction and I can solve. Like if I do the common factor, you know x is a common factor, so I got 2x cubed minus 2, 2x cubed, oh, I just took out the x, so I'm going to keep that 4. Okay, the common factor, I figured out just the x, not the 2. I'm going to keep that 4 over x to the power 4. Now 1x and 1x cancel out, so I'm left with 2x cubed minus 4 over x cubed. And that's my another answer for the f prime. Now let's see what else. Find the equation of the tangent line drawn to the graph of g of x, 2x minus 1 over x plus 3 when x is equal negative 2. Now in the equation part, how do we solve equations? What is the word equation means? Equation means y minus y1 equal mx minus x1. What is tangent means? Derivative into the graph of this at x equal negative 2. So let's figure it out. Y minus y1 equal mx minus x1. That's my equation. Okay, now I need x value is already negative 2. I need a y value. So how do I get a y value? So I'm going to plug in negative 2 in the original equation. 2 negative 2 minus 1, negative 2 plus 3 is going to give me negative 5. So that's my y value. So I'm going to replace the y1 with negative 5, which turns positive because negative times negative is positive. M I don't know, and the x is negative 2, so it's turned positive again. So how do I find slope? M. M means a derivative, tangent, right? A slope, derivative, M, tangent. So I'm gonna take a derivative of this function, g prime x. Now when I'm taking a derivative, I know that's a quotient rule, f in g. So keep the g as it is, the original, times the derivative of f, which is 2, minus, keep the f as it is, 2x minus 1, and by the way, this is a bracket because negative always distribute. Then derivative of x or g is going to be 1. Now keep everything down there, x plus 3 whole squared. Again, distribute, because after calculus we get stuck, then we do LCD, common factor, FOIL, distribute. In this case, it's a distribute. So let's try a distribute, g prime x equal, and by the way, don't even try to do the distribute or anything because they are giving me x equal -2. So I don't want to spend time and making mistakes, so I will just directly plug in that -2 there. I don't want to do simplification when the x is given. So I have -2 plus 3 for the derivative, 2 goes, then I have 2 times -2 minus 1, and of course that 1, and in the bottom I got -2 plus 3 and everything squared. So when I solve this whole thing, I got 7. So 7 is my derivative, is my slope, and this is what the answer is. Okay, show using the quotient rule that if f of x is this, then f prime x is this. It means, show means you have this original function, and that's the derivative of this function, because this is f of x, that's f prime x, but they want you to show them the steps how they got this derivative. So we have to show them the steps how they got this answer for this. So let's try that. So we have to take a derivative of f of x. I'm going to write my f of x here, x squared plus 3x plus 2 over x squared minus 1. And I'm applying a quotient rule. That's f and that's g. Okay, now let's start. So f prime x equal f prime x equal g is going to be original as it is, x squared minus 1 in parentheses, times, take the derivative of f, which is 2x plus 3 in the parentheses, minus, keep the f as it is, so x squared plus 3x plus 2, again the bracket, always do not forget bracket when you have a subtraction sign, close it, times g prime, which is 2x, and close the parentheses. In the bottom, g x squared, whole squared, so that's a whole squared. Okay, let's try this. Now this is going to be foiling in here, and that's a distribution, so let's do the foiling. F prime x equal 2x cubed plus 3x squared minus 2x and minus 3. You guys can do the foiling, you know how to do it. I'm keeping this negative and I'm keeping the bracket and I'm distributing. So I got 2x cubed plus 6x squared and plus 4x and close. And again in the bottom I have the same thing, x squared minus 1 and whole squared. Now I have to distribute this negative. F of x equal, distribute the negative. 2x cubed plus 3x squared minus 2x minus 3 minus 2x cubed minus 6x squared minus 4x. And everything x squared minus 1. If this is a free response, you have to do step by step and show them everything. That's f prime, that's f prime. Now combine like terms, 2x cubed cancel out. Is there anything else that we can cancel? I don't think so. So let's try over there. F prime x equal, I have 3x squared and negative 6x squared is going to give me negative 3x squared. 6 subtract 3 is 3, and bigger number sign we keep, which is negative. And then we have minus 6x, and I have minus 3, and everything in the bottom is going to be x squared minus 1 whole squared. Then I have to fix this around. The bottom one is not a problem because it's already in a factored form. I mean, we can just open it up because if you have, remember, if you have x minus 1 whole squared, for example, then the minus sign will give you one positive and one negative. So it's going to be x plus 1 and x minus 1. That's exactly how we're going to do this. So let's try the factor the top one, and then we can go to the bottom one. And you remember that in calculus, the bottom you do not simplify big time. It's just whatever is easy and whatever makes sense, do it. Okay, so if in this case my common factor is 3, so I'm going to go negative 3 common factor. Then I got x squared up here, so negative times negative is going to give me positive, so I have to have a positive up here, which will be 2x plus 1. And then in the bottom I can open this up, I can say x squared minus 1, and I have a x squared plus 1 because minus means one positive, one negative factors. So this is what I got. Now I can factor this inside the parabola, the quadratic function. Negative 3 stays, and I'm going to factor this. This positive and positive sign means two factors that I have, both of them are positives. So this is x and this is x. This is 1 times 1. And 1 plus 1 is going to give me 2 anyway. And I have a x squared minus 1, and I have a x squared plus 1. Now, if you guys pay attention closely, I have two x squared plus 1, like I have x plus 1 and x plus 1. So I can cancel this with 1, I can cancel this with another one. So 2x squared plus 1 cancel out with both of them. And I showed them because they said show step by step what if we have the same answer. So I think we do have the same answer, and you guys can check back up there. Negative 3x minus 1 whole squared, and that's what it is. They did x minus 1 whole squared, and yes, I made a mistake up here, guys. This one has to be, actually, this one has to be square in square, square in square. So these canceled out, and I'm left with this. You know, that was x squared minus 1 whole square, so it's supposed to be like two of those, x squared minus 1 and x squared plus 1, and both square. Okay, so that's what my answer. Now the question is, if you guys pay attention, there was too much work. We did the quotient rule directly and then applied on this f of x function, and it's too much. Now let's read. Similar to the product rule, there is a valuable lesson that we must learn when we are introduced to the quotient rule. In box below, first factor and simplify the function this from above, then differentiate using the quotient rule. So now they are not telling me to directly apply the quotient rule. They want me to factor it and simplify and then apply the quotient rule. This should be your really thing that you should do it always. You see the question, if you can simplify or factor or do something with it, making more simple, and do the simplification first and then apply any product rule or quotient rule or power rule, whatever the rules are, so you can apply it. Let's do this. F of x equal, I have x squared plus 3x plus 2 over x squared minus 1. Now they're telling me to simplify this or factor it. So I'm going to do it. The factor of the top is two positives. So I got x and I got x up here. Then I have 2 and 1. 2 times 1 is 2. So I got x plus 2x plus 1. In the bottom, I have x squared minus 1. So I have 1 positive 1 and I have 1 negative 1. So the positive cancel out. Now I'm left with x plus 2 over x minus 1. So now it's more simpler than taking a quotient rule of this. Now I can do a quotient rule for that. This is f, that's g. So let's try f prime x. G is going to stay as it is. Derivative of f is just a 1 minus. Keep the f as it is, x plus 2, and derivative of g is just a 1, and then in the bottom it's going to be x minus 1 whole squared. Now f prime x equal, combine like terms or distribute x minus 1 minus x minus 2 over x minus 1 whole square. I multiplied by 1 and I just removed the parentheses and I distributed that negative. So negative and positive cancel out, So I'm left with negative 3 over x minus 1 whole square, which is more simpler than what we just did applying direct quotient rule. You simplify and factor first, and then you go from there. Okay, so that's how you simply get the answer. Now, what is the lesson to be learned from algebraic analysis about? Like simplifying and factoring first and then taking a derivative. So the best thing is to do that. What lesson we learned? We learned if the rational function can be factored and simplified before differentiate, then do it. It will save a lot of time, okay, and there is not going to be messy things. So now they are asking me to find the derivative of a tangent and cotangent and secant and cosecant. I'm going to find a derivative of just a tangent. The rest of them you would understand how to find a derivative like using a quotient rule, but I really want you to memorize the tangent and the cotangent and secant and cosecant derivative. But I'm going to show you just the first one so you have an idea how we're getting those derivatives. So the tangent, if you guys pay attention, the tangent derivative is going to be a secant square theta. The cotangent derivative is negative cosecant square theta. The secant derivative is secant theta and tangent theta. The cosecant derivative is negative cosecant theta and cotangent theta. So these are the derivatives for all of these, which we are going to memorize it because that's how it works quickly. We don't have that much time on the test. So f prime theta is that one. So memorize all of this, but this is the one I'm going to show you how we getting this f prime theta equals secant square theta. So if I'm taking a derivative of tangent theta, I have to make sure that I use the identity, which is sine theta over cosine theta. Now it's a quotient rule. According to the quotient rule, that's my f and that's my g. So let's take f prime theta equal, g stays as it is, times derivative of f is cosine theta minus, keep the f as it is, which is sine theta, and keep the derivative of cosine, which is negative sine theta. In the bottom everything, I got cosine square theta. Now again, f prime theta equal, multiply, so I got cosine square theta, my plus sine square theta over cosine square theta. Now if you remember, I said this before, when you see a square on top of cosine or sine, remember, whether you need it or not, it should click in your head that we have an identity, Pythagorean identity, which says sine square theta plus cosine square theta equal 1. So this is plus sign between them, and this is like a square b square equals c square. So this is my identity. So I can tell this whole thing is equal 1 because that's what it is up here, and I have a cosine square theta. Now 1 over cosine square theta, identity is secant square theta. That's why, because we know that's the inverse of that. So we know that that's how we get secant square theta for tangent theta. So the rest of them, I don't have to do it because you have to memorize it, all of them. Now let's do this question. It says find the derivative of each of the following. So I'm going to find the derivative of them. Let's see, x squared minus 2x, x plus 2. So let's take a derivative of this and then we're gonna figure it out. Derivative of that, can we simplify this first? If you guys pay attention closely, there is nothing there that we can simplify. I can factor out the x. It's going to give me x minus 2, but it doesn't mean I'm canceling or anything. So it's going to give me double thing. It's going to give me product rule and then a quotient rule. So I don't want to do that. I'm just going to keep this as f, that's a g, and take a derivative, f prime x. I cannot rewrite this. That's why I'm directly using it. G stays as a x plus 2. Derivative of f is 2x minus 2. Then we have minus, keep the f, x squared minus 2x within the parentheses times the derivative of g is 1 over x plus 2 whole squared. Then I have f prime x again. Distribute, FOIL, this is a foiling, equal 2x squared plus 2x minus 4 minus, I'm distributing negative x squared plus 2x. In the bottom, we have the same thing, x plus 2 whole squared. Combine like terms. 2x subtract x squared, 1x squared is going to give me x squared, just 1x squared. Then 2x and positive 2x is going to give me plus 4x, and I have minus 4 over x plus 2 whole squared. And this is my answer. I can't do anything else. Done. For this one, I would let you guys do this one because this is f and that's g. And we can solve this. Okay, let me do it then. P prime theta. This is f, that's a g. So g, keep the g as it is. The derivative of f is cosine theta minus, keep the f as it is, sine theta, times the derivative of g, which is 2 theta, over theta squared and whole squared. So now let's do p prime theta again. I can't do anything else here other than theta is the least common, common factor. So I'm going to take out the theta as a common factor. So I got theta cosine theta minus sine theta, 2 sine theta, because that theta is out. So I got theta to the power 4. Cancel out one of them. Then I got p prime theta equal theta cosine theta minus 2 sine theta over theta cube. I cannot do anything well with this and keep it. That's what the answer is. Now, next one is 1 sine theta over 1 minus cosine theta and 3 minus 1 over x, x plus 5. Now, I can start working on this to see how it goes. Let me try this and see how we are going to do this. So, derivative of that. So let's try the derivative of this. I cannot rewrite this. Like you can think of rewriting, factoring, blah, everything, but it doesn't work. So I'm going to say that's f, that's a g. Let's take a derivative. H prime theta equal g stays as it is, 1 minus cosine theta, times the derivative of f, which is sine theta, and the derivative is cosine theta, minus f stays as it is as a sine theta, times the derivative of this 1 minus cosine theta, which will, one derivative is 0 and the cosine derivative is negative sine theta. So it means I have positive sine theta, because this is going to give stays as a negative and the derivative of that is negative sine theta. So negative times negative is positive. So I got positive sine theta over 1 minus cosine theta whole squared. Okay, done. Now let's simplify and distribute. I can distribute this one right there. Like this is, remember after calculus 1 we get stuck 4 operations. Cosine theta times 1 is cosine theta, minus cosine square theta, right? Minus sine square theta over 1 minus cosine theta whole square. Now, if you guys remember, I just said in one question, if you see squares on sine and cosine, then it means we are using identity, Pythagorean identity. But the problem is they have a minus sign between them, and Pythagorean identity has a positive. I mean, you guys can check over here. sine squared theta plus cosine squared theta equal 1. But this is minus. So what do? Okay, the distribute is done, foiling is done, least common denominator I can do there, I can do common factor. So let's try the common factor. What is our common factor? I can do -1. So I got negative cosine theta, because negative times negative is positive, and that's what we get for the answer right there, right? It has to be correct, the signs. So now I got negative cosine square theta, then it means I have to have a positive here. Negative times positive is negative right there. And I got a cosine square theta, and the same goes for that one. Power plus sine square theta over 1 minus cosine theta whole square. Now, if you guys pay attention closely here, now this is okay. This is my identity, which is equal 1. I can apply that. So I got -1 minus cosine theta plus 1. And I got 1 minus cosine theta whole square. Now, there is one more cancellation there. If you guys pay attention closely, this part and this part exactly the same. 1 is positive, left side sign we look for positive, 1 is positive, negative, negative. So they are exactly the same. It's just their signs. If their signs are the same, then we are okay. You can flip them and you can change them around, your choice. But I cancel out one of this. So I'm left with -1 over 1 minus cosine theta. And that's my answer for this one. Now we have another I have another question, which is 3 minus 1 over x plus 5. Now this is kind of question that I can think if I can simplify this, factor, whatever works for this one. So the bottom portion is kind of okay. The top portion is not, because it's 3 minus 1 over x. It's kind of weird. One fraction, one is not. I'm going to apply the least common denominator on the top portion. So let's start rewriting this. So I got least common denominator like this. X times 1 is x. Cross multiply 3x minus 1. And in the bottom, the x plus 5 stays actually exactly the same. Now, if I rewrite this just a little bit more, 3x minus 1 goes on the top, and that's the bottom, and this is also bottom. So if I can push this x up here, it's going to multiply with x plus 5, which is completely fine. Now, what is the next step? 3x minus 1 over x squared plus 5x. Now, this is it is a quotient rule, but it's kind of making it simpler than compared to this one, 2 fractions and stuff like that. So now I'm going to take a derivative of that. This is my f, that's g. G stays as it is, x squared plus 5x. The derivative of f is 3 minus, keep the f as it is, 3x minus 1. And the derivative of g is 2x plus 5. And everything in the bottom is going to be x squared plus 5x whole squared, the original g. Now let's do the distribution and stuff so we can distribute and find out the answer. F prime x equal 3x squared plus 15x minus 6x squared. I'm already distributing my negative, minus 13x plus 5 over, again, x squared plus 5x whole squared. Now combine the like terms, 6 and 3, it's going to give me negative 3x squared plus 2x plus 5 over the same thing, x squared plus 5x whole squared, f prime x. Now what else I can do here? I can factor out the top, bottom, everything. So I can do the same thing we did for the other one. -1 is a common factor, so I can get 3x squared minus 2x minus 5 over the same thing, x squared plus 5x whole squared. Now factor this out, so I'm going to get -1 stays, and if I factor it, I'm getting 3. Since this is negative, 2 of my factors, one positive and one negative. So I'm getting one positive and negative, so I can say x plus 1 and 3x minus 5 over x squared plus 5x whole squared. What else we can do here? Nothing. We're going to leave this alone. That's our answer. So this is how we got this question. Now, Now, for this question, below is a graph of function f of x and let rx equal cosine f of x. It's a quotient rule, and I just already put f and g up here. Is the graph rx increasing, decreasing, or neither increase, decrease at x equal pi? Show your work, justify your reasoning. Increase means we have to take a derivative and figure it out if it's increasing or decreasing. So what I'm doing, I'm going to take a derivative of this r prime x. And since it's a quotient rule, then I'm going to apply g as it is, like f of x. You guys know f of x is not there. So I have to, f of x has a graph. So I just have to write f of x as an f of x. Derivative of cosine is negative sine x minus, keep the f as it is, cosine x, and derivative of g, which is f prime x. Then we are going to do r prime divided by f of x whole squared. Now I do r prime x again, and what is f of x? And since they said at x equal pi, then I'm not simplifying it. I just have to substitute for every x pi. So I have f of pi, I have negative sine pi minus cosine pi, f prime pi over f pi and whole squared. Now f pi means what is the value, y value at x equal pi. Now pi value is actually 3.14, so it's probably up here. This is going right there, which is negative 2.5. We are approximating, so that's negative 2.5, the y value. What is negative sine pi? Sine pi is 0, so I'm going to keep that 0. Minus cosine pi is negative 1 in the unit circle, and f prime pi. So this is a pi. If I take a derivative tangent slope, since this is f of x, and f prime means a tangent, like a derivative, so I'm going to draw a tangent line. It's negative, and I can draw I can keep this line. Since this is a linear function, I can pick any 2 points right there on this line, and I'm going to go fall 1 and run 2 to the right. So that's negative half is my slope for this. And in the bottom, since it's f pi, so it's negative 2.5 whole squared. Now we're going to go to this one, turns 0. Okay, that one is negative times negative is positive, positive times negative is negative. So I got negative half, and in the bottom I have to do this 2.5 and you square it. So I'm going to use my calculator to square 2.5 and square. It's going to give me 6.25. So I got 6.25 positive. Now I got negative half times 1 over 6.25. So negative times, we straight across, we multiply. 6.25 times 2 is going to give me negative 12.5. 1 over 12.5. Since the f prime pi is negative, then we can say that it's decreasing. So the justification is going to be, pick the English from the question. You're going to say the graph of Rx is decreasing because R prime x is less than 0. So that's what it is. That's how you do that question. Now let's try, let f of x, g of x be differentiable functions such that the following values are true. They are giving me x values, all of these. I'm going to write them right here. These are x values. This is f of x. This is g of x, like y values. This is f prime, like a derivative. This is g prime, like a derivative. The question saying estimate the value of g prime 2.5, and I said that several times. If you see the word estimate or approximate of g prime, then it means I'm talking about a secant slope. So since they said 2.5, x value is 2.5, so 2.5 is between 2 and 3. So, and what is the g function, gy values? It's right here and right that one. So I'm going to say this is my f of, this is my a, that's my b. This is f of a, and that's f of b. And why I picked g? Because the function is g. So now I'm going to apply a secant slope. I'm going to say g prime 2.5, approximate. We're going to go g3 f of b minus f of a, which is g2, over 3 minus 2. It's going to give me approximately g3 is -3, and g2 is -1. And again, 3 minus 2 is going to give me 1. I already did that one. Now, again, -3 plus 1 over 1, it's going to give me -2. So that's my g prime 2.5. Let's try this one. It says if px is gx and f of x, what is the value of p prime for? Which means I have to, what is p prime for? The p function that I have to take a derivative of. So I'm going to take a derivative of px first, and then we plug in 4. So again, this is f, that's a g. Do you guys see I'm writing my own f and g because that's how my formula goes? They said keep the g as it is, like f of x times, take the derivative of f, which is g prime x, minus, keep the f as it is, which is gx times f prime x, over f of x whole squared. Now plug in 4 wherever you see x is. So this is 4. So I got f of 4 times g prime 4 minus g4 times f prime 4 over f4 in whole squared. What is f4? Which means I'm looking for a order pair. That's an x. I'm looking for a y value. So 4 is right there. And what is the f of 4? F function is right there, and f of 4 is 1. So I got 1 there. G prime 4. G prime is right there, and 4 is -2. So that's -2 minus, what is g4? Is 7 times f prime 4 is 8. And I have f4, again, that's 1, so 1 squared. So technically I got -2, and 7, 8 is 56 over 1, which is going to give me -58. So the question said, what does this value say about the graph of p of x when x is equal 4? It says the p prime 4 is less than 0, so the graph of p of x is decreasing when x is equal 4. That's what, give a reason for your answer. So the reasoning is right here. I'm going to say p of x is decreasing, because that's what they say. What about the graph of px? Px is decreasing because p prime 4 is less than 0. Done. Because it's negative, then it's less than 0. If q of x 2x squared, f of x gx, what is the value of q prime 2? So if you guys pay attention, q prime 2 means I have to plug in 2, but I have to take a derivative of q. So q is right there, then I'm going to take a derivative of q prime x. Now in q and x, if we pay attention very closely, look at this whole question at the same time. Don't you see they are multiplying, which means I'm going to use a product rule first, because the whole question, when I see it, they are multiplying. So I'm going to use a product rule first. What is my product rule? F prime g plus f g times g prime. That's my product rule. So how do we do this? This is my f, and this whole function is my g, like that. This whole function is g. So take the derivative of f, which is 4x, and keep the g as it is, which is f of x over g of x, plus, because we have a plus, keep the f as it is, which is 2x squared, and take the derivative of g. Now, if you pay attention, g is a quotient rule. How can I take a derivative of this? I'm going to use a quotient rule, you big bracket, and apply the quotient rule. Now, in the quotient rule, which I'm going to go in green, I know in the quotient rule, this is my f, and that's my g. So remember, I'm doing exactly the same what the quotient rule I have been teaching. This is f and g. The pink one is my product rule, which I'm done with it. When I did keep the f down as it is and take the derivative of g is quotient, then I have to apply the quotient rule. According to the quotient rule, keep the g as it is, so g of x, and take a derivative of f prime x minus f goes as it is. F goes as it is, and then we take the derivative of g. right there. And in the bottom, we have gx whole squared. Done. This whole thing is my exactly this portion, the one we are talking about a quotient rule. Now let's fix it around everything. And remember, I said when they give you x value, then do not simplify. So I'm not simplifying it. I'm going to plug in this 2 everywhere. 4 times 2 f of 2 g of 2 plus 2 squared, and then bracket g2 f prime 2 minus f2 times g prime 2 over g2 whole squared. And now figure it out, all of them, and then we are good to go. Now 4 in 2 is going to give me 8. Got that. F of 2, I'm going to go up there in the table. This is f, that's 2. F of 2 is 2. Okay, you guys can check your tables too. Then g2 is -1. There we go. Then this is 2 times 2 is 4, 4 times 2 is 8 again, right there. And then I have to solve this. What is g2? G2 is -1. What is f prime 2 is 9. Minus what is f2 is 2. What is g prime 2 is -1. And in the bottom, g2 is -1 squared. Got it. Now, yeah, let's solve this again up here. 8 times 2 is going to be 16, and it's -16. Then 9 times -1 is -9, and negative and negative is positive 2. So 9, 8, 7, -7 over 1. 8 times 7 is going to give me 56. And it's going to be -56. There you go. And in the bottom it's 1, so it doesn't do anything. So when I add them, I got -72. So that's my answer for this question. Last one, find the equation of the tangent line of the graph Vx, 3x or gx when x is equal 3. Now again, the same thing, they said equation, so I need y minus y1 equal mx minus x1. The tangent means derivative, so I have to take a derivative of that, which is v prime x. We will figure it out this. And also the x is equal 3, but I need a y value. So for the y value, we're going to plug in the original v3 and plug in 3 times 3 and then g of 3. So 3 times 3 is 9. What is g of 3? So that's a g, and 3 is -3. So that's -3. So it's giving me -3 as a y value. So I'm done with this. X value is +3. Now I have to take a derivative so I can get the slope. So this is my f, that's g. According to the quotient rule, g stays as it is, g of x, times the derivative of f, which is just a 3, minus f as it is, and times the derivative of g prime x over g of x whole squared. What is, now again, don't simplify because the x values are given. v prime 3, so I got g3 here, times 3 minus 3 times g prime 3, in the bottom g3 whole squared. So what is g3? That's a g, and 3 is -3. So g3 is -3. Let's try -3 times 3, so which is going to give me -9. I'm just going to write that -9 right here. And then for this one, 3 times 3 is 9. What is g prime 3? G prime 3 is 6. So this is 6 times 9 is 54. Minus 54. In the bottom, g3 is -3 squared, which is going to give me 9. So I got -63 over 9. The answer is -7. So that's my slope. So everything is done. What is the y value? -3, which is going to turn positive. What is the slope? -7x and -3. And that's my actual answer. If you guys have any questions, please comment below and I will explain it again in a separate video.